Alright, corner seats, move your chairs, please. We are going to take notes today on section 5.1, cubic functions. Tonight's homework is page 389. We're going to do numbers 13 through 18. Sign if you'd like, you could sit over there if you want. It's up to you. Group 1, can you report? Number 8. Group 2?
Number 8 and 1.
Group 3?
8 and 9.
Group 4? Ooh, guys. Group 5? Group 6?
Number 10.
Alright, so all of them. We're not going to be able to do all of them. Overwhelmingly, when I was listening though, it's like you guys didn't firmly agree on number 8, I heard, and 12 a lot. Would you agree?
Yeah.
But those are the two big ones? Dylan, read me number 8, please.
2x minus 1 times 2x plus 1 times x plus 1.
Alright, I see that these are a difference of squares right here. So a difference of squares means that this is automatically going to be 4x squared minus 1. And this is going to be multiplied by x plus 4. So I have 4x squared minus 1 and an x plus 4. Sean, help me fill this whole thing out, babe. Multiply, babe. Yep. And here? Alright, Sean, do you see any common terms or are they all different? They're all different, so you're just going to write them out. 4x cubed plus 16x squared minus x minus 4. Number 8. Alyssa, can you read me number 12, please?
0.25x parentheses 12x minus 1 and parentheses 8 minus 3x.
Alright, so we're going to basically FOIL this out. Caesar, 12x times 8x, please. Times 8. Guys, can you put your calculators on your desk, please? I need you guys to be ready. 12x times 8, please. Thank you. Jashawn, negative 1 times 8. Jishan. Mia, 12x times negative 3x. Almost. Yep. And last one, Jessica. Negative 1 times negative 3x. Yep. Plus 3x. Sean, are there any like terms or are they all different? And what, honey? That says x squared, honey. There you go. Destiny, can you clean this up for me? Put it in order from highest power, please.
Yeah, negative 36x squared plus 99x minus 8.
Yep. And all of these need to be multiplied by 0.25x. Alright, here we go. 0.25 is the same thing as dividing by 4. So this is going to be negative 9x cubed. This is going to be 99 divided by 0.25, or times 0.25, which is the same thing as dividing by 4. So that's plus 99 over 4x squared. And then negative 8 divided by 4 is just negative 2, so that's negative 2x. Today we're going to talk about end behavior of our cubics. We spoke a little bit about it yesterday. Tomorrow we're going to do a little dance. So you got to make sure that you remember this because your dance will be graded as a quiz. Yes, you heard me. The entire class will be dancing tomorrow to match the end behavior. So you need to make sure. All right, so here we go. Draw me a pretty big Cartesian plane. And if I have a cubic or any polynomial that looks like this, tomorrow when you're dancing, your body is going to look like, if these are your legs, you're going to have the left hand down and your right hand will be up. Why? Because the left behavior is down and the right behavior is up. So that if you were to put like an imaginary body right here, and I get a pen that works. Dead eagle. If this was your head, and these were your arms, it would look like that. That's your curly hair. Yes. So tomorrow I'm going to be putting up some polynomials and you're going to have to tell me what the end behavior is. End behavior means exactly that. You're only describing to me the ends. What happens in the beginning and what happens in the end. And for this particular polynomial, the way you write it out is you're saying, okay, Miss Riad, if I'm over here walking to infinity, that means if x is going to infinity, my polynomial, which is f of x, is also going to infinity. Don't let me lose you, girl. You with me? But if I'm over here and I'm walking in this direction to negative infinity, so as x approaches negative infinity, this time my function is decreasing, getting lower, 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 lower. So my function is approaching negative infinity. And don't worry, we're going to do this a few times so that you can catch on. Let's do another one so you can start seeing the pattern here. Let's say this time your graph looks like this. Again, I'm only concerned with the end behaviors. Yes, babe. Oh, sorry. Sean, move your back here, please. I've already been over this, bro. Right here and right here. I'm only concerned with the ends. So again, let's say you are walking along the x-axis. This is infinity. This is negative infinity. What you're telling me is as you're walking towards infinity in the x, what's happening in the y direction, which we call f of x. So what you're going to tell me for this one is as x approaches infinity, f of x approaches, well, help me answer this question. As I go to the right, is my function getting bigger and bigger and bigger or getting smaller and smaller? X going to negative infinity. Tell me what's happening. So here you are, walking, 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 walking. Is your function increasing or decreasing? Everybody, is my function increasing or decreasing? So that means my function is also going to infinity. What do you guys think? Doable? So if I give you another graph, I want us to describe our end behavior. Okay? Should I do one more, or you could do one on your own now? Should I do one more with you? Do one more and then do yourself one? Okay, I'll do one more with you and then you guys are on your own. How would you describe this end behavior? Highlight the ends, because I only care about the ends. Josh, help me out, babe. What's happening as x approaches infinity? What's happening as x is getting bigger and bigger and bigger and bigger and bigger? Because remember, this is 0, 1, 2, 3. This is x getting bigger. What's happening to my y values? Right, so that means that f of x is approaching negative infinity. Good job. Samantha, what's happening as x is approaching negative infinity? So here I am walking in the negative direction. As my x's are getting smaller and smaller and smaller, what's happening to my y's? So f of x is approaching what? Beautiful. Now you can do one on your own? Okay, here's your doyo. I just don't want to call it a doyo because that's why this part right here, as x approaches infinity and as x approaches negative infinity, that's a given. That's going to be every single time. Because you have to tell me what happens when you go to the right and what happens when you go to the left. Now this part is what's going to differ each time. Caitlin, what happens as x approaches infinity? What's happening to my y values? Yeah.
Oh, it turns negative.
So tell me what to put. As x approaches infinity,
F of x
f of x approaches
to
negative infinity. Nicely done. So that's how you say it. Mia, what happens as x approaches negative infinity? One more time. Yeah, so how do you say that? As x approaches negative infinity. Approaches positive infinity, which we just say infinity. Okay, we don't have to say positive. What do you guys think? Pretty easy? All right, so that's the first part, and the next part is actually even easier, is how to identify if the functions are even or odd. All right, a nice big cloud so it stands up. I need you to write evens are symmetrical about the y-axis. And odds are symmetrical about the origin. And an easy way to remember this is odd starts with the letter what? O. Origin starts with the letter what? O. So odd, symmetrical around the origin. So when we're dancing tomorrow, we're going to keep in mind about some rules, okay? Every single polynomial is either even or odd, and it's either positive or negative. There's no other choice. Every number in the world, stop looking at the door, please. Yes, sir. Yes, ma'am. Every number in the world is either even or odd, and every single number in the world is either positive or negative. Would you agree? Those are your only choices. Isaiah, can you look at me? All right. if your polynomial is even, I want you to remember the phrase even Steven, which means both of your arms are up if it's positive, both of your arms are down if it's negative. So an example would be anything with an x squared, x to the 4th, x to the 6th, x to the 20th, those are all evens. So if I give you a polynomial with an even power, then you know either both of your hands are up or both of your hands are down. Questions so far? Even Steven. They have to be even. They're both up, or they're both down. But how do you know if they're both up? No. We already know that it's even, but if it's both up, it's because it's positive. If it's both down, it's because it's negative. Y'all with me? Now, yesterday we just did this. Odd, if it's positive, started from the bottom, now we're here. And then if it's odd negative, then it's just in the opposite direction. So for this one, I want you to remember, started from the bottom, now we're here. Those would be like x cubed, x5, x9, x37. Those are all odds. On tonight's homework, I'm going to give you some functions, and you just have to tell me if it's even or odd. After you graph it, you just have to tell me where it's symmetrical. Any questions on how to tell where your arms are going to go? Let's practice for tomorrow's quiz. X to the 7th. So that means tomorrow's quiz, I'm going to put up a problem. Started from the bottom, now we're here. So I should see your left hand down and your right hand up. Okay? X to the 9th. Same thing. Negative x to the 9th. X to the 4th. Even Steven, because it's positive. Very good. X to the 4th. X to the 16th. X to the negative 16th. Very good. Everybody get what we're to do? That's basically what's going to happen tomorrow. I'm going to put them up like lightning quick. And you're going to have to move your arms to the way that to the polynomial. Okay? All right. So on tonight's homework, I'm going to give you something like this. Now we're getting into examples. (3x squared plus 8). Sean, is this even or odd? The power? It's even. And is it positive or negative? Heidi, help me out. If it's even and positive, what should my arms be doing? They should both be up. Good. So if it's both up, I need to know if it's symmetrical around the y-axis or is it symmetrical around the origin. Okay? So this one would be an example, and I'll show you what origin looks like. This would be something that's symmetrical about your y-axis, because it's like your y-axis is a mirror. Whatever's on the left-hand side is the same thing that you see on the right. So if it's symmetrical around the y-axis, we just said, that means that this function is even. And let me show you one that's odd, what that would look like. Example 2, you have like x to the 5th minus 4 to the x, 4x, sorry. Brooklyn, help me out. Is this even or odd power? Odd power. And is it positive or negative? It's positive. What should my arms be doing, Jashawn, if it's odd and positive? Yeah, that's cool. So start from the bottom or start from the top?
Bottom.
Start from the bottom, move up. And this would be an example of something that is symmetrical about the origin. Because if I look from the origin down this way and up this way, they are the same. I don't go left and right anymore. I stand at the origin and I look to the left and I look to my right, and it's across from each other. So this would be odd. Notice I'm graphing them for you But you're gonna have to graph it tonight. So you have a graphing calculator. I don't expect you to do this by hand. I expect you to just put it in the calculator and graph it. If you don't have a graphing calculator, then what do you have to use? Desmos, okay? Do not spend an hour on tonight's homework. I don't care if you know how to graph. I want to know, now that you have the graph, can you tell me if it's even or odd? So this one would be one that's neither. Let me give you that example. So if you have 2x squared minus x minus 1, look at that. It's not symmetrical about anything. If I put my mirror right down the middle, yeah, though you don't look the same. Are you in agreement? Do you guys see that? If I put my mirror right here, do you see how this side does not look like that side? Yes or no? Yes? So it does not look like this, where it's the left and the right look the same. Nor if I stand at the origin and look to my left and look to my right, do those look the same? Or this, do they look the same? No. So this would be an example of a function that is neither odd or even. Take out your calculators, please, and tell me, for your doyo, x squared minus x. Is it odd, even, or neither? Graph it and tell me on your calculator. If you have a graphing calculator, can you show your group before you put an answer? Show them the graph and then decide. Do you guys not have one? Thank you.
Yeah.
Talk to each other and decide, is it odd, even, or neither? I still don't know the schedule. Third period, 11:21. Give me a summary, please. Today I learned